Yes. Okay, so the first question here comes is, what is statistics, right? What is statistics and why we use it, right? And the third question is, what is biostatistics, right? So what is statistics? Statistics is nothing. Let's start with statistics. What is statistics? Okay, so statistics is nothing but, you know, getting the output. Output here means the presentable form. Okay, presentable format of results. So the process, okay, the process of raw data, okay, process of raw data to the results, okay, results, and not only the results, presentable results. Okay, so presentable results means either in the numbers, means when I'm talking numbers, it means the text or the tables or the figures, right? So this is like when we have the raw data. Suppose, let's start with an example. Okay, let's start with an example. So I asked you guys to go to the community, and I asked you guys and go to the community and collect the data of the pregnant women. Okay, data of the pregnant woman means, first of all, three parameters let's take. Okay, like this is, first of all, you will give some ID number to the patient, right? Then you will be, I asked you to check the weight of the pregnant woman and age of the pregnant woman and how many months pregnancy is, or how many weeks we can say, okay, pregnancy is. Three things. So first of all, like 1 2 3 4 5 6 7 8 9, right? And if we check out their weights, what is their weight? Suppose someone is having 56, someone is having 53, someone is having 42, someone is having 46, someone is having 78, someone is having 35, someone is having again 58, right? Age 18, 23, 29, 36, 24, 18, 19, 23. Okay, this is like 9 people are there, right? 9 people. Sorry, I think I mistaken somewhere. 3, 3. Okay, these are 9 only, but here I have written 8. Okay, somewhere it's okay. 38, right? So, okay, still very less. Okay, 9, right? Still 9, right? So we have 9 candidates. We have 9 candidates, age, weight, and how many months, right? How many months? So when I'm talking about how many weeks, not months, sorry, how many weeks are there? So someone is like 8 weeks pregnant, someone is 34 weeks pregnant, someone is 27 weeks pregnant, someone is 32 weeks, someone is just 2 weeks, someone is 18 weeks, someone is 5 weeks, someone is again 21 weeks and 24 weeks. So this is the data of the study you did, right? The mentored study, whatever you are, you did the data, right? You did the collection of data from the community. You went to the community and collected this data. Can someone from this data, directly, when they are looking at this data, can tell me some results? If I ask them, okay, if I ask them, what is the weight, okay, what is the weight of, like pregnant women in 18 to 25 years of age group. Can you tell me by saying this? Mean weight, right? Mean weight. Can you please tell me? Anyone? Can you tell me, like, directly looking at the data in first instance? You don't have to calculate. At first instance, can you please tell me what is the mean weight of the pregnant women in 18 to 25 years of the age group? Can someone tell me? No. Answer will be definitely, you have to calculate. You have to calculate, right? So if I'm answering this question, suppose if I'm answering this question, how will I answer? How will I answer? Suppose my question is mean weight of 18 to 25 years of the age group. So first of all, what I'll do is I will filter. Okay, I'll filter the age. So 18 to 25. 18 to 25, 1, 2, 3, 4, 5, 6, 7 are there, right? 7 are there. So what I'll do is, if I want to check these, their mean weight is, I'll write 18 plus 24 plus 23 plus, this is the age, not the, this is the age, right? So this is the age, not the, this is the age. So I'll just delete it, age. Okay, so mean weight I have to calculate, right? Mean weight I have to calculate. Okay, mean weight I have to take for all, right? So what's the mean weight here? 56 plus 53 plus 42, or plus 42, yes. And then last 4 plus 45 plus 78 plus 35 plus 58 divided by how many are there? Out of 9 there are 7. Out of 9 there are 7. And then we can tell this is the mean weight. So statistics is nothing but simply mathematical calculation. Okay, mathematical calculations of the scientific data, to get the results to fulfill the outcomes or aim or objectives of any study. Okay, this is called the statistics. This is called the statistics, right? You understand? So if I am representing the mean weight, so if I'm representing the mean weight, maybe it will be, suppose 49.7 kg plus minus 10.5 kg, right? 10.5 kg. This is the mean weight of my woman. What was my question, right? So this is the answer. I will write like this. Okay, I will write like this. Or what I'll do is I will prepare, if I'm asking the comparisons, like like tell me what is the mean weight comparison between 18 to 20, 20 to 40, 20 to 30, and then 30 to 40 years of the age, right? So you will be telling me that, okay, one is 49.7, one is 38.8, one is 53.3, right? This is how you are representing the comparison of weight in 3 groups, correct? This is how you are representing the weight comparison in 3 groups. But if I want to represent in other formats, how will I represent it? I'll show in the bar charts. Okay, I'll show in the bar charts. This is 49.7, this is 38.8, and this is 53.3. So here, see, look at the difference between 3 things. One thing is, if I am showing just the chart, if I'm just showing the chart, nobody can make out. Okay, nobody, actually nobody, because data is not just the 9 numbers. Data is in hundreds and thousands of the numbers, right? Not only 9 but thousands of the numbers. So no one can make out directly. Okay, the second thing is, when we do analysis, we get some numbers, and by looking at the numbers we can check, oh, this is the difference. So the age group of 30 to 40 has the highest weight, right? And then if this is for scientists, okay, this is for the people who are educated, okay, qualified, okay, but who are looking at the data for the first time, and this also takes time, maybe seconds only, maybe 0.2 seconds, okay, but this is like there is no need to look at, there is no need to use the brain, just look at the diagram. Which diagram is higher? This one. This group belongs to 30 and 40, this group belongs to 20 and 30, this group belongs to 18 to 20. So which one is higher? This one. Anyone can see at this data and can say, oh, this group of women has the highest weight in the pregnancy, right? So statistics means using the mathematical data to get the results of your study, to represent your outcomes with aim and objective. That is the direct and simple meaning of the statistics. Okay, and when I am talking about biostatistics, okay, when I'm talking about biostatistics, so what do you mean by biostatistics? Biostatistics means nothing else but utilization of utilization of statistics in bioscience. Okay, bioscience means what? Bioscience is very vast. First of all, as we are from the health science area, that comes under bioscience. That means in healthcare also, medicine, right, pharmacy, right, genetics, right, and there are many more, many more means there are thousands. Okay, palliative care, okay, palliative care, okay, and then physiotherapy, dental, okay, and I mean occupational therapy, imaging, I mean whatever healthcare science has the wings, all the wings we do need to do, I mean we do need to do the research, and wherever is the research we need statistics, and that statistics is nothing but the biostatistics, and we use the biostatistics to get the results from the driven data which is coming by the studies, right? So first is health science, and second thing in this, if we are there are many other things like agriculture, okay, agriculture is bioscience, marine is bioscience, okay, marine is bioscience, agriculture is bioscience, and there is food technology, okay, there is food technology is bioscience, and basic science labs, data, I mean whatever basic science is also the bioscience, like botany, geology, chemistry, physics, these all are the part of our bioscience, okay, and wherever we use the statistics in such cases we can go ahead with that. Is there any protocol need to follow or not to determine the range of age group, or we can do at our ourselves as per need? It is actually as per need. There is no specific protocol to determine the age groups, but it is totally as per your need. But always try to keep in mind that whenever you are deciding the age groups, there will be similar gap, okay, there will be similar gap, right? If I'm telling first, like 20 to 25, 25 to 30, 30 to 35, 35 to 40, usually 20 to 35, 26 to 30, 31 to 35, 36 to 40, 41 to 45, okay, and then 46 to 50, right? Like that, there should be unique gap, there should be equal gap, or 20 to 30, 31 to 39, sorry, 31 to 40, okay, 41 to 50, then 51 to 60, then hello guys, there was a power cut actually, so I lost the network. Okay, no worries, that's okay. So I'm just sharing the screen again, right? So yeah, as you can see, as I was talking about, there must be, I got a question from Mahesh that what would be the age group and what would be the criteria to decide the age group. So there is no specific criteria to decide the age group. You can choose any criteria based on your needs, but there'll be always equal, what we say, the gap between the age groups. Okay. Unit matters. Yes, unit matters. Always unit matters. Whenever we are checking anything, there would be a unit. Okay, there will be unit. I mean, SPSS will not take any unit. Okay. When you are entering the data, SPSS does not require any kind of units to be entered in that. Okay. SPSS will take only the numbers and analyze those numbers. But units you should have for your convenience, like in which unit you are analyzing the data, either in kg, lb, months, whatever. Okay, this depends on you in what kind of things you are taking. Like suppose the question is actually right. Like suppose I want to okay, like suppose I have to define the age. Okay, I have to define the age, right? So age is here, right? I have written the age, right? I have written the age. I hope you are visible. It is visible to all of you guys. It is okay, great. So if like I have to show the age, so I have written the age here. So age, if I'm writing 2 years, 5 years, 6 years, so that is like unit in the years, but year is not required in the SPSS. SPSS will just take 2, 5, 6. Okay, and you have to analyze and get the results. You can also write 24 months, okay, and 60 months and 72 months. You can write in the days also, whatever 1000 days, 2500 days, 2300 days, 3300 days. So whatever unit you are writing, this is just in numbers. Okay, SPSS will take just numbers and will give you the data in numbers only. Okay, SPSS will not tell you which unit you are entering, which unit you are analyzing, but this is you in which units you are collecting the data. Okay, and which units you are analyzing the data. Like suppose this is the age, but if I'm talking about height, right? If I'm talking about height, so height, you just have to enter the number, either that is 1.7 meter, 1.52 meter, 1.34 meter, or 1.00 meters, or 0.99 meters. So this is in the meters. I can write in the centimeter also, 171 centimeter, 152 centimeter. This is meters. I can write in the centimeters also, 134, 199, right? This is in the centimeter. So SPSS will just take the numbers, okay, and it will give the analysis in the same numbers. Okay, if you want, you can write in the inch also, 5 feet 70 inch, okay, 5.7 inch, 5.6 inch, 5.3 inch, 5.2 inch, 4.1 inch, whatever, right? Whatever, you have to give the data in the any unit. You just have to give the numbers to SPSS. It will count, it will give the results in the same unit. Okay, and unit will not be written here after this or this or this. That you have to decide what unit you have entered, in what unit you have. So this is in the simple terms, whatever input you are giving, okay, whatever input you are giving, you will get the same output. Okay, in case of units. Okay, SPSS will not change any units by itself. Okay, SPSS has the power. SPSS has the power to calculate the units anyways. Okay, SPSS has the power to calculate the units. You can calculate the units. You can change or convert the data into different units. You can convert the data into different units. You can use the mathematical formulas like multiply, dividends, okay, addition, anything, percentage. You can get any mathematical formula done in the statistics. Like suppose I have taken the height in centimeter, okay, and I want to change it to feet and inch, right? Feet or inch, so feet and inch. So what I will do is, when I'm changing this, I'll just keep a formula. Okay, I'll just keep a formula like this variable I have written in the centimeters, all centimeters. Okay, and I want in the feet and inch. So I will apply the formula, and the next variable will come up with the feet and inch. Okay, so how many foot or feet, whatever it was there, and how many inches there was the height, right? So everything will be converted, but that is not automatically it will do that. You have to put the formula. You have to put the formula, whatever formula is there. Like I want to convert, I want to check the BMI. Okay, I want to check the BMI. but I have only the weight and the height of the patient. So definitely no problem. In one variable you have weight, in one variable you have height. Just put the BMI formula, okay, kg divided by meter square, and another variable will come as BMI. So this will not show the formula, but automatically you know the BMI formula is kg divided by meter square, like heights, correct? So that is the power, that is the power which is already there in that, but you just have to apply the formula, right formula at the right time, correct? So you can do it, understand? Now my question, two questions I have solved. One is, what is statistics? I hope you understood. Okay, I hope you understood what is statistics, right guys? Understood? And what is biostatistics? It was not a rocket science, simple. You know, statistics is the mathematical formula to get the results out of the raw data, and biostatistics is the use of statistics into the biology or bioscience, correct? Two things. Now the third thing is very important, the data. When I'm sending you, when I'm sending you to the community, suppose I send you to the community, same question is there, go and collect the data of pregnant women, okay, pregnant women, right? Pregnant women, for what? Like I want to see the impact of education and occupation, okay, occupation on development of GDM, impact of education and social and occupation on the development of gestational diabetes. That is my question. Impact of education, how the education is impacting the people, impacting the pregnant women, and occupation, how it is impacting the pregnant women to get the GDM, correct? That is my question. So what are the parameters guys you want to collect? Tell me, what are the parameters you want to collect? Can we, okay, Dr. Abitan is asking, can we put those formulas in SPSS table itself? No, there is no SPSS table. You cannot put the formulas in SPSS table itself, but there is the converter, and there are the converters where you can put all the formulas, okay? There are the exchanges, there are the converter where you can put the formulas, and your data will be automatically calculated and stored in the different variable. So that means only in the tables only you can do it in the data editor window only. I'll tell you everything, don't worry, okay? When we are practicing SPSS, I'll tell you. So I'm just telling you how you can do and what is the power, what can be done in the SPSS, okay? So now my question is, can you please tell me what kind of data we need to collect for this study? Please tell me guys. Okay, so first thing, suppose name of the patient, or let's not think of name of, like ID of the patient, right? Then again age, right? BMI, I'm not going to age and weight and this, definitely that will be there, but I'll go to the final thing, BMI, age, BMI, okay, and duration of pregnancy, right? Now the main thing here is education level, okay, and occupation, okay. And then suppose if they have any children before, okay, if they have any children before, right? These three things, or yeah, these 4-5 things, let's take these 4-5 things and let me make a table, okay? First thing is I collected age, then I collected, this is for like 5-6 will take, okay, I have age, then I have BMI, then I have your duration of pregnancy, then I have education level, right? Education level, then I have occupation, then I have number of children's already having, okay, number of children. This is very interesting class guys, I'm very sure you will be understanding everything. So this is the data set what I'm getting at the end. This is the, sorry, wrong line, okay, this is the data set what I'm getting at the end, correct? This is the data set what I'm getting at the end, and I have not only one, but I am collecting the data for suppose 10 people. Let's not take many, but this is the ID. Okay, so 1, 2, 3, 4, 5, 6, 7. 7. Okay, let's take 8 only, not 10. Okay, so age of the first woman is like in the late 40s or maybe late 30s, like 40 suppose. Second one is younger one, then 23. Someone is pregnant in at the age of 18. Someone is 24. Someone is 31. Someone is 28. Someone is 90. Okay, this is just the age, and their BMI is suppose BMI of this is 24.8, BMI of this is 31, lady is 30.2, this is 18.6, this is 22.4, this is 25.6, this is 28.2, this is again 19.3. So I think this is 23 again. Okay, this is the BMI. Duration of the pregnancy, if I say in the months, that is 3 months, that is 2 months, that is 4 months, that is 5 months, that is 6 months, that is 8th month, that is again 1 month, that is 2 months, right? That is 2 months. So this is the there. Education level, if I divide into 3 or 4, maybe let's divide into 4. First is illiterate, like who did not see the college. Okay, so I will write I, and maybe the high school, H, I will write H, and then maybe the secondary school means 12th class PUC, so higher secondary I'll write S, and if they are having any degree, right, so I'll just write it. Okay, so these are the 4 education levels. Suppose occupations, many are housewife. Okay, housewife, 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 and then one is in the corporate. Okay, one is in the corporate, 2 are in the corporate, and then 2 of them are working in the agriculture field or as a laborer, agriculture or laborer, right? Let's see, agriculture or laborer. So how many are done? 8, all 8 done, right? And then number of children, like suppose this has 0, this has 1, this has 2, this has 0, this has 3, this has 1, this has 0. Okay, this is the number of children. This is the number of children. So I hope guys just write if you understood this data. Did you understand the data and objective of the study, what I'm doing here? Did you understand that? Yes or no? Tell me. Did you understand the data? I mean, collection of data. I'm not asking about the data, but collection of the data. Tell me. Did you understand the collection of data? If it is correct or not? Correct, I feel. I did it correctly, actually. So do you feel it is correct or not? Tell me, guys. Yes. Okay. So this data is actually correct, right? This data is correct. Now let's see. Now I would like to talk about the main thing of today's class is data types. Data types. Okay, data types. So tell me, how many types of data is there? First of all, I mean, usually, what do you know about data? Tell me types of data. How many types of data do you know, guys? Tell me fast. Tell me the types of data. 2 types of data. Now write the names directly. Don't tell me 2 types or 1 time. Just write the name. Which type of data do you know? Categorical and numerical. Okay. Categorical and numerical. Yes. Anyone else who wants to put the comment? Analytical and descriptive. Suruchi, analytical and descriptive. Numerical. Quality data and quantitative data. Till now, nobody is exactly correct. Yes, guys. Anyone else? Okay, let me tell you. Okay, let me tell you. So overall, okay, overall, there are 2 types of data. Okay, 2 types of data. One is focus. quantitative. Okay, another one is qualitative. Qualitative or quantitative, which be whatever. Qualitative, we also can write it qualitative. Okay, qualitative and quantitative. So what does it mean by quantitative? Okay, when I'm talking about quantitative, that means countable. That means countable. Okay, countable. We can count it, measure it. Okay, countable or measurable, right? When I'm talking about measurable, that means I'm talking about numbers. I mean, everything is in the numbers, but the numbers which can be which can be counted or measured, like 1 2 3 4 5 6 8 9 10, whatever is there. Okay, whatever is there, 10.1 10.8 100.1 100.5 100.6, whatever that we can measure. Okay, the second thing is qualitative. Qualitative data means there are groups. Okay, there are groups, and in the groups, whatever is there, that is countable, but the groups are not countable. Categories are not countable directly. Okay, so usually we call it quantitative data. There is a quantity that is measurable. Okay, and qualitative or categorical data is not measurable. Okay, categorical data or quantitative data is not measurable. Understand? Now, let me tell you again. Scale ordinal are different things. Scale ordinal are the data in SPSS, not outside. What is outside data? Let me tell you outside data. When I'm talking about quantitative data is again two types. Okay, quantitative data is again two types. One is continuous. Okay, and then is, yes, discrete. Okay, continuous and discrete. And categorical data is also two types. One is ordinal, one is nominal. Okay, ordinal and nominal, right? Ordinal and nominal, correct? Got it? There are four types of data. You basically two types of data, of I mean the widely. One is quantitative, one is qualitative. Quantitative means which we can measure. Qualitative means we cannot measure, but there are groups or categories, whatever. Now the quantitative data is also two types. One is continuous and discrete, and qualitative data is also two types. One is ordinal and one is nominal. Now let me describe one by one. What is continuous data, guys? What is continuous data? So continuous data is whatever is having, continuous data means whatever is having there are three major differences. Continuous data means there is no specific limit. There is no, usually there is the decimal in between. Okay, decimal in between, right? And the third very important thing in continuous is that there is the huge range in the data. Now let me tell you how. First, if I'm talking about blood pressure, like blood pressure could be 60 mmHg also, blood pressure could be 200 mmHg also. Huge range. Okay, and data is huge, 60 also and 200 also. Blood pressure also could be 10 mmHg, right? Blood pressure also could be 240 mmHg in hypertensive emergencies or stroke patients, right? I mean, that is the huge thing. Blood pressure could be anything at any range, right? If I'm talking about weight could be 1 kg, weight could be 200 kg also, like 168, 140, 168 kg, anything it could be. So the data which is continuous is like having the huge range, okay, and limits are not there. Okay, there is no specific limit. You cannot define. Okay, you cannot define the minimum and maximum in that, right? So there is no limit or no minimum maximum in the continuous data. Okay, and then usually there could be, you can keep the decimal. See, weight you can calculate in 1.2, 2.2, 1.40. Height you can do in, you know, like 1.7 meter, 1.62 meter, like, or in centimeters also you can do. I mean, multiple things are there. Weight also you can calculate in pounds. Okay, decimal will be there. Age you can count. Age you can count in like 1 year, 10 year, 100 years, 60 years, 80 years, whatever is there. 80 and a half year, 50 and a half year, whatever, you know. But there will be, you know, usually a big range and no limit, and usually we can keep decimal. Okay, that type of data is continuous. Okay, so let me go back for, there is a question for you. In this data set, which categories are continuous type of data? Which categories are continuous type of data? Tell me, guys. Tell me the continuous type of data. There is age, BMI, duration, education level, and your occupation, number of children. Age, BMI, okay, duration of pregnancy. Anything else? Okay, so there are three things, if according to you. One is age, one is BMI, one is duration of the pregnancy. Yes, duration of the pregnancy could be one of the continuous data. Definitely age is the continuous data, BMI is the continuous data, duration of the pregnancy could be one of the continuous type of data. Correct, it is definitely right. You are absolutely right. Number of children, let me come to that. Now in that, when I'm talking about continuous data, that is all about continuous data, right? Now if I want to talk about the discrete, okay, discrete data is also numerical, right? I mean, numerical, or what we say, you know, quantitative, right? Numerical or quantitative. So this is also in the numbers. So discrete is where we have limit, where we have no decimal. Okay, where we have no decimal, where we don't have big range, and that can be easily counted. Like what? Like number of children in the family, 1 2 3 4, maximum 13 15. Okay, not like 24, but it is like not big range. Number of cars, 8 5 6 10 15, usually 20 5 1. Number of this. Now in the patients, number of asthma attacks, right? 2 3 4 in a week or in a month, 10 5 6 8. Okay, and then like suppose not only this, but like number of asthmatics, number of readmissions of the patient, number of readmissions of the patient. Okay, like 3 times, 4 times, 6 times, 8 times, 9 times, 15 times, whatever in a month. So this discrete type of data is like which is countable easily. Okay, which has the limit. There is no decimals. We cannot tell there is 2.5 children. We cannot tell there is 3.2 children. We cannot tell there is 4.5 children, right? When I'm talking about number of cars, we cannot say there are 8.5 cars, right? When I'm talking about number of asthmatics, we cannot tell there is 3.5 asthmatics. Not at all. If I'm talking about number of readmissions, we cannot tell the patient was admitted for 3.5 times. Not at all, right? So these have some specific range, the minimum and maximum range, and there is no decimal and easily calculatable. Okay, easily we can calculate them. So that kind of data is called as discrete data. Okay, that kind of data is known as discrete data, right? So this is the discrete data. And now if I tell you, if I show you my data set, can you tell me which one is the discrete data set? Tell me which one is the discrete data set, guys. Tell me which one is the discrete data set. Which one is the discrete data set? Number of children, right? Number of children is the discrete data set here. Correct, absolutely correct. Now, if I go to the categorical data, if I go to the categorical data, so let me talk about the categorical data here. Let me talk about the categorical data here. Okay, let me talk about categorical data. So, as I have written categorical data, okay, categorical or qualitative data, right, is two types, right? One is categorical. In the categorical also, like ordinal, right? And another one is nominal, right? So what is ordinal? See, everything is categorical here. Either it is ordinal or nominal. Okay, everything is categorical. Categorical means what? If I'm talking about hypertension categories, then there is like either like there is one where there is no hypertension, one, two is mild hypertension, okay, or maybe the stage one we can say at JNC, according to JNC, stage one, stage two, stage three, right? So there are the stages. Okay, height, right? Height, not in meters, but height we can confirm by tall, medium, right, and short, right? This is the height when we are categorizing it. Okay, and when we are talking about severity of the disease, mild, moderate, and severe, right? When we are talking about these things, if I'm talking about blood groups, okay, so like I'm talking about ordinal data type. So there is the rank, there is an order. Ordinal means there would be two things, okay, I mean one thing only in different thing, either order or rank. Okay, in the data there will be order or rank, and that's why this type of data is called as ordinal data or ranked data. Ordinal data or ranked data. Like severity, mild is the smallest rank, moderate is the medial rank, and severe is the highest rank. In the hypertension categories, no hypertension, like category 1 is this, and highest category is stage 4. In this, you can keep anything. Tall is the highest category, shortest is the smallest category. So there will be the rank, okay, there will be some order in the categories. I mean, there will be the categories, but there will be some type of order in the categories or rank in the categories, right? In our data, see, in our data, one, education level. Okay, education level is nothing but ordinal type of data, ordinal data or ranked data, right? Ranked data. Why? Because we have illiterate, then we go to higher school, then we go to higher, I mean this higher secondary are right here, then we'll go to college, then we'll go to post graduation, then we go to doctorate. This is the rank, this is the rank system, this is the order system, right? So in our data also, ordinal data is there, that is the education level of our pregnant women, right? Now after this, let me talk about something which is the second category, and the second category is either non-ordinal. If I write, I mean that is not the name, non-ordinal, non-ranked. Okay, so that type of data is called as nominal. Okay, nominal type of data. Okay, nominal type of data is, this is also the categorical data, but there is no rank, there is no what? Order, right? So what, like what? If I'm saying that, are you coming to party? Okay, what you will say? Yes, no, or maybe. Okay, is there any rank in this? Yes, no, or maybe? Is there any rank in yes, no, or maybe? Yes, guys, please tell me. Is there any rank in yes, no, or maybe? Or just yes, no? Is there any rank? No, there is no rank. But still there are categories. Either yes or no or maybe, right? Simple. I am checking 6 people's blood group. Okay. One is A positive, one is B positive, one is O negative, one is AB negative. And whatever, there are 4 blood groups, right? Is there, so all these are categories, right? Is there any rank or order in blood groups? Tell me, guys. Is there any blood group which is like highest and something is no, something is lowest? Is there any rank? Is there any data which is in the order? Is it? Okay, let me give you another very basic example. Religion, simple, right? Religion, Hindu, Muslim, Sikhs, okay, Christianity. Is there any rank which is divided by the our what we say, our constitution or anything? Is there any rank in the religions? Is there any order in the religions? No, there is no. So religion is also one of the categorical data, but type of nominal. Okay, type of nominal, right? And then the next thing from our data itself is occupation. Occupation, someone is lawyer, someone is doctor, someone is scientist, someone is rickshaw wala, someone is bus driver, someone is agriculturist, someone is housewife. Is there any rank or order? Who is higher, who is lower? Is there any rank in the occupation? Tell me, in the occupation, any rank? No. If I'm talking about in a system of, like in the company, there is manager, senior manager, director, then there is rank. But if I'm talking about occupation, there is no rank, there is no order, right? There is no rank, there is no order. Correct. So that is the rule of biostatistics. Okay, that is the types. These are the types of biostatistics data type. Okay, so first is quantitative, right? Quantitative, and quantitative also 2 types. One is continuous, one is discrete, right? Number 2, qualitative, right? One is qualitative or categorical, right? One is ordinal or ranked, one is nominal, right? Nominal, correct? These are the 4 types of data. Now there is some more thing, some more special things, like when I'm talking about nominal data, guys. Nominal data, okay, I mean there is no rank, right? And no order. But if I'm just talking about, see, very important to understand, 2 or more than 2 categories. 2 or more than 2 categories in nominal data. Okay, in nominal type of data, again, either 2 categories or more than 2 categories. Okay, so if there are 2 categories only, if only 2 categories, then this type of data is called as what, guys? Tell me. What kind of data it is called as when there are only two categories? What type of data it is called as when there are two categories in nominal? Are simple, two categories is binary data type, binary data sets. Okay, binary data sets. There are only two categories, then because we got it either binary or dichotomous. Yeah, so bi is means two, and dichotomous also is two. Okay, so either binary or dichotomous type of data. Okay, like let me give you the examples of binary and dichotomous type of data. Suppose again I'm asking you, are you interested or not? So what you will say? Yes or no? Simple, right? This type of data is categorical. So what are the things there which you have to keep in mind? First thing is categorical. Yes. No rank. Yes. So categorical, nominal type, and only two categories. So these three things, if it is fulfilling, that means this data type is either binary or dichotomous. Okay, binary or dichotomous, right? So one is yes and no. Okay, one is yes and no. Second example, can you give me the three examples of binary data? Three examples of binary data. Three examples of binary data, guys. Please give me three examples of binary type of data or dichotomous type of data. Yes. Binary data or dichotomous data. Three examples. Yes, guys. Then I'll take a 5-6 questions quiz. I'll ask you, and then we'll close the class. Basics of data types. Yes, tell me. See, these things are very important. You have to understand, because when I'm going to the data sets analysis, you must be very clear either data is continuous or categorical, because every analysis is depending on continuous or categorical. Continuous or categorical. What type of test you are using, if the data is continuous or not continuous. So parameters, as I told you in previous classes, I'll tell you parameter data, parametric tests, data must be continuous. Non-parametric data must be anything. Okay, so everything is depending on these things. So that's why I'm giving you more examples and asking you more examples to give, so you can understand the data types later. Every analysis in SPSS will be depending on these things only. This is the base. This is the perfect base of understanding the SPSS and analysis. Every analysis is depending on the data types. Okay, so give me the three examples of binary data, guys. Oh, nobody is writing here. Come on. Smoking, non-smoking, married, unmarried, pass, fail. Yes, correct. Male, female. Absolutely. So, yes, pass or fail. Married or unmarried. If gender, if we are dividing only two, male or female. Simple, right? Male or female, pass, fail, or dead or alive. Simple, right? If we are talking about dead or alive. Okay. OPD, IPD, right? Simple. And if there are categories more than two, we are immediately removing from the dichotomous or binary data type. Okay, got it, guys? Important. Done. So now tell me one thing. Tell me one thing. Whatever I taught here, other than that, give me 5 examples of continuous type of data. 5 examples of categorical type of data. Categorical, which is ranked. Yes, give me, think of, because it's very important to understand. Yes. 5 examples of continuous data type. Tell me. Height, weight, BMI, I have already written. Age, I've already written. Other than that, what is the continuous type of data? Tell me. Clinically, non-clinically, whatever. Yes, guys, please tell me. Marks. Okay. Population. Average, no. No. Are simple. See, if I'm talking about this patient only, if I'm talking about these patients only, look at this. Look at the what I'm writing now. Any investigation. Okay, any investigation. FBS, if I tell, it could be 10 also, it could be 500 also. FBS, blood pressure, heart rate, GlyHB, PPBS, okay, calcium levels, thyroid levels, whatever blood investigations you are doing. Other than that, you know, there is, and everything is there. There are a lot of things which can be in the continuous type of data. Okay, so by the time when we will be analyzing, we'll be coming to know. Okay, and then tell me 5 categorical data types. Yeah, salary is there, definitely salary is there. Salary is continuous. So type of categories, tell me type of categories, guys. Now tell me the categories. Number of ANC widgets. Number of ANC widgets and OPD widgets are strictly discrete. Food habits. Race, yes. Race. Food habits. Food habits. If not only veg or non-veg. If it is only veg and non-veg, then it will be dichotomous. But if it is not, and guys, I'm asking about the ranked data. Either of this is not ranked. This is nominal categories. Race is against nominal category. How can you rank the race? How can you rank the food habits? Do you think non-veg people are top or high or having the highest rank? Not at all. Logically, this is not the categorical data or ranked data, what I'm asking, ordinal data. Okay, this is not the ordinal data. Food habits, race, and religion are the nominal type of data. Yes, mild, moderate, severe, I told. Pain score, yeah. Pain score is perfectly fine example. Pain score, 1 to 10. Yes, rank. Okay, then what else could be rank? Cancer stages. Okay, hypertension stages. Okay, education level, right? Education level. Okay, and rank in the office, I mean designation. See, here I'm not talking about occupation, I'm talking about designation. Sorry, designation. Okay, either at the lower level or higher level, administration level, there is the rank. Okay, so these are the examples, multiple examples which can define the ranked data, which can define the ranked data, and it is important. So these all will be important for the analysis. Okay, any questions now, guys? Any questions till now? And we'll end the session here. This is the important thing what I wanted to tell you today. Okay, the introductory part of biostatistics, and that will be there everywhere. Let me tell you, everywhere. Yes, tell me. Grades, yes, grades are there. Level of post, designations, emotional levels, yes. Depression levels, yes. Anxiety levels, yes. Ranked data. Okay, any questions? As per data, we need to make changes in the settings in SPSS well or not. Let's keep the SPSS away right now. But yes, I'll tell you how to convert the data, how to enter the data, how to see the data. Everything I'll tell in SPSS. Don't worry. I'm here. Okay. Yes. Any questions? Okay. If no, then we'll take off. And I hope, what is that? Which topics of biostatistics we are covering? Today we have covered the data types, which is the basic, or what we say, the foundation of biostatistics. We have covered that. Okay. And in biostatistics, we are covering all the basics only. Descriptive analysis means, and inferential also, like I'll be telling you all the inferential, which tests where to do and what kind of test we have to select. And then we will immediately jump to, after 2 more classes, we'll jump to the SPSS, all the tests. So all the lectures, in all the lectures, the basics and all advanced of the biostatistics will be covered. Don't worry. I mean, if you are asking theory, then theory basics, 2 more lectures of the basic theory of the biostatistics, and then we will jump to the SPSS. Don't worry, everything will be, going smoothly, and you will be understanding everything. That's, I'm very sure. Okay. I just didn't want to miss the today, today's lecture, because I'm back, so I should teach you something today. Okay, so take care, guys, and we'll see you in the next class. And if you guys are free, I can take it tomorrow also, maybe, but let's see. I'll ask you. Okay, usually today was the day of the class, Thursday and Fridays, right? So if not tomorrow, then Thursday definitely, but I'll ask you if anything. I'll ask you if we can take the class tomorrow. Okay, take care, guys. Good night. Bye bye. Thank you.